Oh, okay, what's up guys? Mr. Rebella solving equations using multiplication and division. So before we did addition and subtraction. Today we're doing multiplication and division. So let's take a look at some of the rules. So we already learned from the last class that if you add one thing to both sides of an equation, the equation stays true. If you subtract the same thing from both sides of an equation, the equation stays true. So same idea with these two properties. So the multiplication property of equality states when you multiply each side of an equation by the same non-zero number, the two sides remain equal. So this is the key difference here. Non-zero number, because if you multiply anything by zero, it turns into zero anyway. So it's not really a way to solve an equation, because otherwise you'll just end up with 0 equals 0. So for example, if you had on this side, on the left side, it says 8 divided by 4 equals 2. If you multiply by 4 on each side, those cancel, and you get 8 equals 8. Okay, so if in even more simple terms, if you started off with like 5 equals 5, that's a true statement. If I multiplied both sides of that by 3, then you would get 15 equals 15. You get the same thing. If you had 5 equals 5 and they only multiplied the left side by 3, you would get 15 is equal to 5, which is not a true statement. So the point of this is to isolate the variable. So you wouldn't use that with all numbers. So in algebra, this is x, some number x divided by 4 equals 2. So right here, this x is being divided by 4, so you're doing the opposite to that. So you're going to multiply both sides by 4. And if this isn't super clear, this is x over 4 times 4. So this actually becomes 4x over 4, and then you know that you can cancel the 4's. So you just end up with x. Okay, so, but you don't have to show that step each time. Just know that it gets canceled out. So x equals 8. And then, of course, you can check your answer. This is the solution, and you plug that back into the original equation. So to check your answer, you go, okay, 8 over 4, does that equal 2? Yes, so 2 equals 2, then you did the problem correctly. Okay, and over here it says the multiplicative inverse property. The product of a non-zero number n and its reciprocal is 1. We've done this already. So 5 times 1/5 equals 1. So if you take the reciprocal of a number and you multiply it, then you get 1. Same thing works in algebra. Some number, 1 over that number, and you end up with 1. So if you did up here 7, 1 over that number is 7 over 7, which equals 1. All right, let's move on to the next property, which is the division property of equality. So this says the exact same thing, basically, except, well, it's dividing. When you divide each side of an equation by the same non-zero number, the two sides remain equal. So again here, different from addition and subtraction, it is by a non-zero number. So you cannot divide by 0, which will give you an undefined answer. Okay, so here this is 8 times 4 equals 32. If I undo that multiplying by 4, I divide the left side by 4 and the right side by 4, you get 8 equals 8. The same idea applies in algebra when there's an unknown. So 4 times something equals 32. Well, this said times, so I'm going to undo that by dividing. So if I divide by 4, on both sides, I get x equals 8. And again, you can check that by plugging in what you say 8 is to the original equation. So this says 4 times x. Instead of x, I'm going to put 8. Does that equal 32? And then, yes, 8 equals 32. So what we're doing when we're solving, we're actually transforming equations. So this is just a reminder of what transforming is, so that your goal is to isolate the variable on one side of the equation, either the right side or the left side by itself. Always perform the same operation on both sides of the equation. I'm going to say both sides a lot. And then to undo an operation, perform its opposite operation to both sides. So if you have multiplication, the opposite is division. If you have division, the opposite is multiplication. If you have addition, the opposite is subtraction. If you have subtraction, the opposite is addition. So if I had this solve w, some number w divided by 4 equals 12. So this is it looks like a fraction, but the fraction bar is division. So I'm going to rewrite it over here. W over 4 equals 12. So I know that I'm dividing by 4. So it's nice to show it this way. I'm going to multiply by 4 on the left side and multiply by 4 on the right side. It doesn't matter if I show it like here or on the other side. This is fine. And then you know that these cancel. 4 over 4 cancels because this is actually 4 over 1, right? So 4 over 4, they cancel. This is W equals 48. And then again, you can check your answer by taking this 48 and plugging it into the original equation. So if I'm going to check, I'm going to put 48 divided by 4. Does that equal 12? 12 equals 12. So I did my problem correctly. And here, okay, this is where it gets a little more challenging. I'm rewriting it again. 2/7 x equals 6. So that's saying I have a number, I'm multiplying it by the fraction 2/7, and it's going to equal 6. Well, what do you do when you're multiplying? The opposite of that is division. So I'm going to divide. So this is going to look not like so intuitive, but this is 2/7 x divided by 2/7. What does that look like? Well, if I'm dividing by 2/7, I'm going to do 2/7 x still, and then instead of dividing, I'm going to multiply by the reciprocal, 7 over 2. Okay, so I'm going to put this over to the side to show why I got 7 over 2, and just take a shortcut. Whatever this coefficient is, if it's a fraction, I'm going to multiply by the reciprocal, like that, on that side, and I'm going to do it on the right side as well. So as you can see here, it's really nice. The 7s cancel, the 2s cancel, and all you're left with on the left side is going to be x, okay, equals, and then now you just multiply across. You can cross cancel right there. This is a 1 and a 3, and so you get 21. So again, I'm going to take this 21 and plug it into this x to check my answer. So it was 2/7 times 21. Does that equal 6? Okay, so if I do this, I get 42 over 7. Does that equal 6? 6 equals 6, so I did my problem correctly. The ones with fractions as coefficients, that's going to be kind of the toughest one to get used to. But once you see the pattern, it'll be very quick. But it's because of this, because you're dividing by that fraction. But when you divide, you actually multiply by the reciprocal. So it's easier to not show all this extra stuff that I did there and just multiply by the reciprocal on both sides. Okay, let's try some more. We're going to find the area of one of these things. I'm not going to do all of them, but a rectangle, you have an area of 45 square units. Okay, so the area equals 45. So remember that area equals length times width. So that's the key when you're doing one of these kind of problems where it doesn't give you the equation. You have to write what the equation is. So, and then fill things out. So here, my area is 45, and that's the A. So I'm going to replace the A with 45. The length, we'll say that's x is a length. So I'm going to say that's x. And the width is 5. That's W. And I'm just going to put the 5 next in front of the x. So 45 equals 5x. That makes sense because 5 times x equals 45 when you multiply them. So to solve this, I'm going to do the division property of equality. 5 times x, I'm going to show division like this with the fraction bar. I'll show that, and it's kind of nice because I can cross cancel the 5s, and then that becomes 1. This is just x on the right side, and this is 9. And then again, I can check my answer. If I said this is 9, 9 times 5 equals 45. So I'm good there. Okay. Moving on to this. Let's try this part B. 2y divided by 8 equals 7. So this is like 2 parts, kind of weird. So I'm going to go one by one. I'm going to multiply by 8 on both sides. I'm going to say 2y divided by 8 times 8 equals 7 times 8. So divided by 8 times 8, that they cancel each other out. So I'm just going to be left with 2y equals 56. Okay, and then I'm going to divide both sides by 2. because y is being multiplied by 2. So I know that my 2's cancel. So y there is going to be, so my y is going to equal 28. Okay, let's take a look at this. Area of the parallelogram shaped courtyard is 2,730 square feet. What is the length of the sidewalk? So again, area for a parallelogram is base times height. So, okay, we know that this is 65. We'll call that the base. I don't know what the height is. That's what it's asking for. The length here would be considered the height because it's perpendicular to the 65 feet. So that's going to be my h, the length of the sidewalk. Okay, and then a is 2,730. So bigger numbers, but we know that we are multiplying 65 times h, so we're going to do the opposite of that, which is divide by 65. And then so we get 42. And then so this is in feet, so 42 feet. Okay, a word problem here. You and your 4 friends. Let's see here. You and your 4 friends buy tickets to a baseball game. The total cost is $70. Write and solve an equation to find the cost of each ticket. So let's assume that each ticket costs the same. So you and 4 friends. So it's you and 4 friends. So how many people that's 5 people buy tickets to the baseball game. So let's think about what our variable is going to be. We'll call it C. C is going to, I'm going to let the variable C equal the cost of each ticket. Okay, so if I bought 1 ticket, I'd be paying 1C. There's 5 of us, so 5 times however much the tickets are is going to equal $70. All right, so this is 5 times C, so I'm going to divide both sides by 5. That cancels, so C equals 14. And this is in money, so $14 each ticket. And I know what you're thinking, like, you probably are reading this and going, okay, well, yeah, you just divide 70 by 5. But I want you to get used to being able to write and solve an equation, especially writing the equation for this, because sometimes it'll be more complex than just you and your 4 friends buy tickets. Maybe there'll be a problem where there's been concession stands, you're buying hot dogs, you're buying food or souvenirs or whatever. So basically, I know you can do this in your head, maybe, but get in the habit of knowing how to write an equation. Okay, so our last one here, a slush drink machine fills 1,440 cups in 24 hours. Write and solve an equation to find the number of C cups each symbol represents. So if you can't see the symbols here, we have, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 30. We have 30. 30 cups. Okay, let's see how much each symbol represents. So right here it says 24 hours. It doesn't really matter what that is. We don't need that. So the drink machine fills 1,440 cups in 24 hours. Well, how many is that? Well, each of these symbols represents 30 cups, so 30C. So let C equal number of cups each symbol represents. Okay, so now all we need to do is divide by 30 and know that that cancels out. Okay, so that's going to be, let's see, 48. So each cup represents 48 actual cups. Okay, so hopefully that was helpful, and I'll see you guys next time.